Our Math 30-1 Diploma review, we're starting with functions. For this video, we're going to try to do functions, transformations, and exponents and logs, depending on time. So the black on these is like the standard. So it's the curriculum outcome that you're trying to make sure that you know how to do. So the first one is sketch graphs that is a sum, difference, product, or quotient of two functions. So obviously all four things you got to know how to do, but we're going to go over just one of them. Okay, but if you need to figure out quotient, then go for it. Okay, it says how to. Identify the points. Oh yeah, I got to come over here now. Identify the points on the given graph with the same x-coordinate. Before the indicated operation on the corresponding y-coordinate, determine the new value, the y value, and the x-coordinate. So don't need that anymore. Sorry, not PDF. Okay, and let's make this a little bit darker. Okay, there we go. All right, so what we want to do first is, it says sketch for the example. So this example is to the above there. F of x plus g of x, and it just gives you the picture. Okay, it doesn't give you a table or anything. So first thing we want to do is we want to go ahead and make kind of just like a little grid here. Okay, we have our f of x, we have our g of x, and then we want our f of x plus g of x, which is what they asked for. And the point is that one thing a couple of you guys are getting confused on is maybe your x's are your inputs. Those don't change. The outputs change because you're changing the function, but the inputs are the inputs. So for example, on this one, we're just going to do the simple inputs of 0, 1, 2, 3. Okay, and we're just going to see what those graphs are doing at those spots. Okay, so if I'm looking at f of x, so it looks like f of x is this guy. Okay. Sketch f of x of g of x. Okay, so we got that. All right, so at 0, what's it doing? Okay, good, 0. 1, it looks like it's 1. Okay. 2, yeah, it looks like they have a 1.3 in the notes, which is fine. We're kind of guesstimating a little bit. And then 3, they put 1.8, just for reference. Obviously, you wouldn't have to guesstimate if you were given, if it was asked to be exact. You have to have some information to find that. G of x now, if we go 0, so g of x at 0 is -4. -3 at 1. 2 is 0. And 3, what's it look like there? 4? No, a little higher than that, isn't it? 5? Looks like 5. Yeah, that looks good. Okay, 5. Okay, good. So now you identified, and this is what I was kind of, a couple of these, there's one of these on your final, is that simply if I want to know what f of x of g of x, and let's just say I'm kind of going off tangent here, if I said at 2, at the point 2, what you do on those cases, you just simply go to the f of x graph, you go to the spot of 2, and you add the 2 y's there. That's all you have to do when you're looking at a picture. Okay? So that's what you would do. But if you want f of x plus g of x values for all those points, you simply just add those values. I mean, either way, it's the same thing. But if you just want to look at the graph, you still can do it that way too. All right? So we'll erase this because we're going to do all of them. So f of x plus g of x of these 4 points, 0 plus -4, so it's -4 at 0. So what that means is the function of f of x plus g of x at 0 is -4. The function of f of x plus g of x at 1 is -2. At 2, it's 1.3. And at 3, it's 6.8. Okay, so again, the x values don't change. The outputs are what change. Okay. Okay, going on to the next standard there if there's no questions. Okay, write the equations of a function of the sum or difference product quotient of two functions whose equations are given, then determine the domain and range. So we're going the domain and range off of that. And so with domain and range, a lot of times we're going to be looking at the division ones, what stands out because division has restrictions. So the example we're going to look at is f of x equals x plus 7, g of x is x minus 3. Determine what h of x is. Okay, so if we got h of x, we know h of x then is x plus 7 over x minus 3. So let's just look at that for a second. What's our domain? Yeah, domain is x can't be 3. What's the range? Close. Yeah, its range is y can't be 1. Because y, what's the horizontal asymptote? Horizontal asymptote is y equals 1. How do we get that? X over x. Coefficient of 1 over 1 because they're the same degree. Okay. What's the vertical asymptote? It's 3. Okay. And that's all the information they want for this one. Any questions or concerns with that? Good? Okay. Let's go ahead and go to the next one here. All right, next page. All right, so determine the values of composite functions given the equations of the functions that form a composite function. So we're going to determine the values of f of g of x, okay, and at a certain value. So for example, we have f of x and g of x. We're going to do f of g of 2. So if I write that in composite, though, remember that is this. That's what that is. I want you to know that's the same thing. This right here and this right here is the same. Okay? And so what we're going to do is we're going to put g into f, and then we're going to plug a 2 in for x. Now, the thing you got to realize is you actually could put the 2 in now and then put that number into f of x. That works as well, however you want to do it. That's probably easier because you're not doing as much work with variables. So I could put the 2 in for g and get 7. G of 2 is 7. I can now put 7 there and get my answer. Okay, and that gets me 20. 3 times 7 minus 1, so f of 2 gets me 20. So f of g of 2 or f of g of 2 is 20. Okay. Now, using the graph, okay, using the graph to determine it. So if we do, we're doing 1, so f of g of 1 for this one. So that means what is g at 1? So g at 1 is what? So here's g. So yeah, so g of 1 is negative 3. So then what's f at negative 3? D and E. F is here. There is no values in negative because it's a radical graph. So this is a does not exist. So when we tried 1, it didn't exist. So that means that fg of 1 does not exist. Okay? Now, if we take the 2 though that we just did, we do it with the graphs. Let's just do that for practice. So if I do 2, so then g of 2 is at 0, right? G of 2 is at 0. So what's f of 0? 0. Okay. So if I did the f of g of 2 with the graph, you would get 0. Okay. And it's the graph. It's not the same as that. So if you're thinking, why isn't it 20? Well, these are different. Okay. Okay, good. All right, so a couple other things here. Given the equation of two functions, determine the equation of the composite function and determine the domain. So very similar to what we just did. So we got how to. So for the functions f and g, composite f of g of x is formed by substituting g in for x in f of x. So we are doing f of g again. Again, I want to write the other way because you will see this as well. Remember, this is the same thing as this. Okay, so that means I'm taking 2x and putting it right there. So then f of g of x is square root 2x plus 1. That's it for that one. Okay, just one more, and we'll talk about transformations. Okay. All right, so the one more here. So given the equation of two functions, sketch the graph of a composite function. Okay, so we want to graph it. So that means we just gotta do the composition and then graph that what's left over. So I'm still doing f of g, so I'm still taking this, I'm still putting that in for x. This I do have to square out or FOIL out in x minus 1. Actually, I don't, technically, and we'll explain why. So here's what it is. Why don't I have to? This is just what type of form. You should know this from Math 20. That's like the standard form, the vertex form, right? That means the parabola shifts right 1 and up 3. So that's all you need to know, right? So this graph right here is going to be right 1, up 3, and goes like that. Okay, on to Unit 2. Okay, let's talk about our transformation stuff. So here's the forms that we look at. Okay, so your horizontal stuff comes from B. B is a stretch of 1 over B, right? We flip it from the equation. So B is a horizontal stretch of 1 over B. What does it mean when B is less than 0? Reflect on the y. Good. Okay, and then the last piece of horizontal we know is the C. Move opposite of what you see. And that's left and right. Okay, so our vertical stuff, we know A, that's our vertical stretch by A. What's it mean when A is less than 0? Yeah, reflect on the x. Okay, and then we know D is our vertical translation. And that's, I put normal. It's not opposite or anything. Okay. Here's a good little chart for helping invariant points. So I'm going to erase this left and right thing for right now so we can write this in here. So invariant points is simply points that don't change. Okay, so then I want you to say what would the invariant point be for those specific moves. So what wouldn't change? Good, so y equals AF of x. So if you do a vertical stretch, remember that does not affect your x-intercepts. So this is your invariant points are your x-intercepts. How about if I do y equals negative f of x? So that's flipping over, same thing. It's still x-intercepts. Because this is the one that flips over the x-axis, right? When you flip over the x-axis, stuff on the x-axis is not being flipped. It's staying there. Okay. f of b of x. Yep, the y-intercepts stay. When you flip over the y-axis, again, the y-intercepts stay. And do the inverse. What stays the same? Yep, you guys are saying it. All y equal x spots. Or, for example, the point 3, 3, right? When x equals y, those will be invariant. Remember, invariant is not intersection points, okay? Invariant is not always intersection points. Remember the ones we had where they flipped? The -2, 4 and the 4, -2, those weren't invariant. Okay, so keep that stuff in mind. Okay, what parameters affect domain? B and C, right? Our B and C affect our domain within that function. Okay, your horizontal stretch will affect your domain. Okay, it's maybe moving it or flipping it. Your moving right or left affects your domain. Okay, what parameters affect your range? A and D. And that makes sense. Domain X, horizontal, range Y, vertical. Okay. Okay, so we'll just finish up transformations today, and you guys will do logs tomorrow. Okay. All right, so order of applying transformations. How do you, unless otherwise specified, always perform stretches, reflections, and then translations last. Okay, so I guess SRT is something people use it for, but it doesn't matter to me. You guys should know that. Stretch and reflections are multiplication things, so it's just your order of operations. Translations are plus or minus, which makes sense in terms of order of operation. So example, the point 38 lies in the graph y equals f of x. The graph is transformed to this stuff, or the new coordinates of the point after all the transformations performed. Okay, I'm going to pause the video. I want you guys to go ahead and try this, and then we'll do it together. All right, I'll start working on it as you guys are finishing. Just like I said out loud there, make sure you pull that 3 out so you can see your actual horizontal translation. So it's y equals -2 f of 3 times x minus 3 minus 7. Okay, and like what I like to do is I like to go and just put it into my point mapping. So I just kind of put my x here, my y here. So what's happening to my x? My x is being stretched by 3, which is 1 over 3. And it's right 3, so plus 3. My y is being stretched by -2, and then down 7. And now I just plug in the point 38 and figure out where that's been moved. Okay, so 1/3 of 3 is 1, plus 3 is 4. So my first point is 4. My second one is 8. So -2 times 8 is -16. Minus 7 is -23. So 4, -23 is where you'd go. Yep. Uh-huh. Yeah, you do it your own way, it'd be fine. I would just make sure you're showing the steps of what you did and identifying what you did. So like with the written, put more than less, right? So like since Cash, you know that -2 is a vertical stretch, just write -2 vertical stretch, right? Down 7 vertical translation, and just write things you're doing. That way, if you just mess up a negative, then you'll get most of the points because you identified 3 out of 4 translations. Does that make sense? Yeah, but it won't matter for that for sure. Yeah. When it comes to that, we're going to have a day. I'm going to try to find the day that we're all here for sure, but we're going to have a day where we focus on the written stuff, and I'll get some exemplars up here. Okay, last one here, and we'll stop for today. All right, switch to the x and y equation on your graph to get the inverse. So remember, find the inverse. You flip x and y and solve. Domain becomes a range. The range becomes a domain, so the x and y stuff flips. Okay, so determine the inverse of y equals 2 to the x. Express your answer in exponential and log form. So we know that x equals... So y equals 2x. If I want to find the inverse, then we have to go x equals 2y. Now, one thing you should stand out for sure here is the thing we want, when we want to get this equation solved, we want it to be in y equals form. Well, y is an exponent. That's very difficult, except for that's why we have logs. So write this in log form. In log form is log base 2 of x equals y. And that's why we kind of jokingly told you guys, everybody's like, I don't know what a logarithm is. It's an inverse of an exponential. That's the point. Okay, they're inverses. So the inverse of y equals 2 to the x is log base 2 of x equals y. Okay, if it wants an exponential form, let's see, did they give us another one? Yeah, so then there was another example that was done here, it's not on the page. If you did y equals x minus 1 squared, okay, and we found the inverse of this one, it'd be x equals like that. So if I'm doing this, I'm just solving now, so I got root x, and then add 1. Okay, so one thing I want to point out here, and it was on your final, it's been on your review. When it says, what do you have to make the original be to make the inverse be a function, you need to think about the vertical line test. Okay, we need to visualize, so the example that is used a lot is when you have a parabola like this and use the inverse of it, the inverse parabola is like this. This is no longer a function. And so the point is you really need to go either left or right of the vertex on your restrictions to make the inverse a function. Because if you don't, then you have both sides of parabola, which makes you have like a vertical line fail, right? So if I just said that this right here was, let's say the vertex of the original is 2, 3. That means 2. I want x to be greater than equal to 2 or less than equal to 2 when it says stuff like that. Okay, because I want only half of the parabola. Okay, and so why I'm showing you this is because see where it says plus or minus? We want the plus or the minus. We don't want both of them. Because if you have both of them, then it's going to be the top and the bottom piece there. Okay? All right, so we'll stop there.